Hello. Today, we will talk about digital avatars. What you see has been created by an automatic process.
Hello, welcome back on Delta 3 Innovation Lab channel. Today we are going to talk about digital avatars. Before starting, let me introduce my buddy in crime, Gianni Rosagalina.
Hello,
Gianni.
everybody. Hello, everybody.
And our special guest, Sebastiano.
Hi guys.
Hello, Sebastiano.
Sebastiano, please, tell us some things about you.
Yeah, first of all, thanks for the invitation, guys. And I'm a Microsoft MVP for AI category, and I deal with artificial intelligence and computer vision since 20 years now. And nowadays I'm focused on NLP and, of course, as you can see, vision. So producing digital avatars.
What is the difference of a different type of avatars? Let me explain. Using video games, kiosk, totems, we saw different digital avatars. Can you explain us the difference?
Yes, so basically, first of all, today we already know that thanks to Facebook and Nvidia, but even Microsoft, there is an explosion of the interest on avatars thanks to metaverse. Anyway, when talking about avatars, of course, we think just to animated puppet like 3D models that interact in a real world. That could be the metaverse produced by Facebook or what was in the early 2000 games like Second Life. So basically, we are talking about 3D models inside a 3D world. And this is a kind of avatar and is related to this kind of interaction. Another kind of avatar is much more digital and can be used in solutions like totems or web chats, where basically you have a 2D avatar. Of course, you can interact with it, but we are talking about two different kinds of technologies. And the first one is produced again using 3D models. It is much more computer vision than AI. In the second in the second case, or at least in this case that we are talking right now, this avatar is created using deep learning. So totally different approach. In my opinion, there's no need to have our religion war where talking about where is the best. Of course, based on your goal, there is the better solution. What I can say is that when we talk about the virtual world, right now, you can't reach a photorealistic result if this is important to you. Instead, when we talk about 2D avatars like this one, produced thanks to artificial intelligence or better deep learning, we can reach the photorealism. And of course, it depends on your needs.
Very, very interesting. And the different kind of different field of application.
Well, talking about our business, for example, we have several fields of applications. That first of all is the customer care. Nowadays, we are accustomed to use the classical web chat fueled by NLP engine that could be the Microsoft Bot framework with Lewis or other NLP engine. But today, the new way is to have a side avatar having, of course, a human aspect that helps in interacting with the human. And in some situation that could help from a business point of view. And this is of course the main application, but one other great application is for interactive totem. As company, we already did a project like that, and of course you can imagine easily the difference between a standard totem where there is a simple video and something that where you can interact, you can talk with the avatar to produce questions and answer. Is a totally different approach and a new way. This is something still new, and we as company, but also other companies are going to invest a lot of resources in the near future for this application. But also there are other field of application that think on devices. For example, we are going to plan to add this feature, for example, in devices like Alexa, but is still a work in progress now. And last but not least, for example, in automotive, that is a field that you can say, wow, why automotive? Well, we had a request, of course, made by special companies producing high expensive cars. So we are not talking about cheap cars, but almost like supercar having inside a digital avatar with a photorealistic aspect to interact with.
I agree. I believe that the interaction is the core for this kind of products. I saw also application in the healthcare sectors because, as you can imagine, from the psychological point of view, a patient can interact in a better way with an avatar with human aspects.
Yes, that's true, but there are several problems that are not technical problems. What I mean, let's talk, for example, about psychology, and it's very complex to produce a solution like that because it's a very cutting the edge situation, and is not possible, is not right maybe to produce an automated process that gives suggestions to some kind of problems. So in this case, for healthcare, yes, could be used, but much more like customer care. For what you said, an hybrid situation could be something that like already did, for example, in NVIDIA, in a paper that I read, where you can replace the doctor, but on the other side there is not a robot, but there is someone that is chatting using the web chat, but having a real person that can interact with more than one people at the same time, but a human on the other side. So in
Another
this case,
example.
okay, it could be applied in healthcare, but it's risky for that reasons.
In another example, in healthcare or similar situation, I remember some projects I also did in the past, probably almost 10 years ago or even more. it was using virtual avatars for sign language, or translate automatically text to sign language and produce signed sentences, for instance, for weather forecast or train station messages.
Yes, this is an interesting application, and yes, I agree. That's another field.
Anyway, we are non-business guy. We are a technical guy, and we wanted to uncover the secret sauce of this digital avatar. Can you
Yes,
share with
for
us
sure.
some things more technical?
Yes. So we already talked about where it is an avatar and feeds of applications. So go straight to the core, and I will explain my current workflow, because this project has been created really since 1 year, more than 1 year now, and changed a lot. So today we will talk about the last results and the last techniques and the last workflow. Why I'm talking about the workflow? Because we are friends and we talk to each other a lot of times, and we all agree that AI is not magic. So it's not enough to produce a very good machine learning model and believe that executing it, everything will work fine. There is a lot of job before to prepare data. That is something really, really important that is underestimated, let's say. Here, I will tell you all the process, starting from the shooting. And yes, we are talking about shooting, because to create the dataset, we did everything from scratch. Even finding and using real people taken from friends or paid actors, and we designed also each single step starting from the shooting. When talking about shooting, is not just taking a small movie of the character, but there was a team in this case that studied a specific text. They are a degree in languages, they are computational linguists, and studied each word, each sentence that the actor have to reply, have to speech during the shooting, in order to cover each single phonema or DCMA. And so this is a very, very important step. Also because the quality of the voice, how the actor speech has a great impact on the final result. Let's talking about me. I know that I have a really bad voice. My R is not perfect. And for sure, compared to another person that has a better voice, that will produce a better result. And this is already the first aspect. So we had to study with a lot of attention and changed a lot of times the text that we used. Because each sentence, each word has a different sound that must be replied for the future. I don't know if we have a video of the short video of the backstage, else we can continue.
Okay, I will share. Show it.
Pronta.
Yes, Steve. Well, that's not what I meant, but it's okay. I don't think it's fine, but it's okay.
This is a very important step.
Sorry, Sebastiano. During the video, we can't hear you. Can you repeat what you say?
Sorry.
Okay.
Yeah, I said that, as you can see, it's a professional set. We paid a lot of attention for the quality of the video, using not only the green screen, but, for example, all the shootings has been made in 4K, and we used software like Adobe Premiere, After Effects for the green screen optimization, and that's not AI. So in this case, in our case, to create something like you watched at the beginning of the event, you don't need just skills in deep learning or machine learning, but also skills in this kind of fields and linguistic computational notions, because you have to know exactly what is the best text. So after that stage, we have to switch to audio processing, because it's another key aspect. And after that, the training, of course, of the model. And here is being studied a specific sequence. So each step of the training is the result of more than 1 year of mistakes and optimization that I did.
Sebastiano, I have a question.
Yes.
Just to better understand, so which is the input of the system? Meaning we just see the output. So we have the video of the virtual avatars, but what's the input? Now I see just the video, the shooting, but which is the process?
So thanks for the question. We will see better in the next slide, but basically the input is a reference frame of the character and 2 audio input. We will see in detail. Thanks to that 3 inputs, we can produce the final frame. So after that, the deep learning model, is able, based on that 3 inputs, to produce just 1 frame. Of course, you have to repeat the inference for each chunk of the audio to produce the full movie. Everything is put all together using a tool that is well known, like FFmpeg. We will see better after. So, talking about audio processing, we cannot talk about audio processing without the Fourier transform, or better in this case, the short-time Fourier transform. Well, what it is the idea behind it? First of all, so we said that we have to work with the audio, and like for the shooting, also I used software like Adobe Audition to clean, for noise removal, so for the optimization of the raw input. And then I used the short-time Fourier transform in order to split each audio produced, because the input is a text. On the real input, we start from a written text. Then we call a text-to-speech service. The audio that is produced, we apply that workflow that I'm going to tell you, and then the input of the deep learning model is the reference frame and the audio produced using those algorithms. But we start from a written text. So let's say that we already choose our text, and then we already did our speech to text. So what are the next steps? With the short-time Fourier transform, we split our audio, our word, in very small chunks. Let's say 40 milliseconds. There is a reason why that value, because we work with a video having 25 frames per second. The audio is 60,000 hertz, and so there is this is the best value for each chunk. Anyway, for each chunk we apply the Fourier transform, so we extract some feature of that chunk based, and to that chunk we match a single frame. So based on the fact that we have 25 frame per second, and there is that sampling frequencies for the audio, we have 40 milliseconds. Anyway, that's not enough, because the short-time Fourier transform extract all frequencies, but there are some situations that we have to take into account. For example, the humans can detect sounds from 20 Hz to 20,000 Hz, but the human voice starts from 100 Hz to almost 3,000 Hz. So the extra frequencies are not only useless, but could be dangerous for the algorithm, because it's an amount of information that could affect the final result. So we apply an algorithm that is named MFCC, that basically what it does is to apply some kind of transformations to those frequencies in order to highlight the human voice frequencies. So basically this is what is done, and also applies a logarithmic transformation, because as you can read, always because of the human ear specifications, low sounds are better recognizable than high sounds. After a threshold, your ear works in a logarithmic way. So we can leverage this situation to compress some frequencies, but what it is the final goal? Not only to extract better our working frequencies, but also to reduce the amount of information to use as input for our deep learning model. Why? Let's say that a good parameter for Fourier transform is 4096 samples that you have to half, and then we are talking about more or less 2000 parameters, 2000 input that you should use in your deep learning model. Using this algorithm, you can reduce everything to 128. 128, of course, also this is a parameter. You can choose if you want to use even less or much more. But let's say that 128 is a good value, and you know as a deep learning expert that if you reduce the amount of data as input, the better it is. So this approach helps us also from this kind of point of view. So, but there are also several aspects that are very, very important. I studied a lot. You have no idea how much I studied. There are also other parameters like the hop length, the overlap length, and the window length. What it means? Okay, we said that we have to extract 4,000 parameters, but how it works? It works applying a small filters for each sample, like the convolutional operation. But how wide must be, let's say, the kernel, and does the kernel must overlaps or not? This is very important, because if you wrong something, even very, very small here, it can affect all the final result. So, based on several studies, I found that the best option for hop length, having a video with 25 frames per second, and these parameters, 60,000 hertz mono for the audio, the best option for the hop length is 614, sorry, and that's not enough. That's still not enough, because I will explain better here. This is what happened exactly. So let's say that you are working on the frame, on the E frame, okay? But is that frame enough? Because we are talking about a very, very small chunk, 40 milliseconds. And the sounds of A, let's say for example A, could be different if I'm speaking the word USA, or another word with the A, because it's important what there is after and what there is also before, because the position of the lips could change even if the sound in that small chunk is the same. So to choose how much to overlap and how wide must be this interval is very important. The problem is that if it's too large, it's a problem, because of course the sound is no more unique, and if it is too small, is not enough to understand the current sound. So the idea, and this is a technique that I developed and took a lot of studies. Basically, when I told you that the audio is made by two inputs, what I did, I started from that situation, and then I said, okay, let's create a two-dimensional input. So, where the first line is the center frame. In the second line, we have the previous frame, and in the third line, the frame after. So, is a kind of image, so I can apply a 2D convolution after, and in this way, I realize better from a deep learning point of view what happened around me. With a window length of 1, so the exact and the correct interval. On the other side, we have to highlight and to have to explain better to the deep learning model that the center audio is the key, is the most important part. And so I pass as additional input the value of the center key, but with a window larger too. So it's a different value. Using this approach, I really cover all all the sound of the situation around me. So, how to prepare the data set? Because we talked about the input, but how to produce the data set? Of course, I created a dedicated software to do that, but basically, as a summary, what I do is to create an algorithm that is able to extract the most important sounds inside the shooting, that is more or less 6 minutes. So we are able to create everything using a shooting of 5-6 minutes. But I don't use all the sounds, all the audio, but I extract with an algorithm the most important sounds. For each of that sounds, I add, to the data set not only that sound that is named here the center, but also 2 frames before and 2 frames after. So this is done after a lot of attempts, and I realized that that was the best solution.
Sebastiano, before going deeper in technical details about the model, could you generate now an avatar with a text? For example, AI is not magic. Let me show you behind the scene.
Yes, for sure.
You answer too quickly, so I don't know.
There's something that can be done.
Okay.
Let me just check. Here, as you can see, I use neural voices of Microsoft AI to check if all parameters are okay, and that's true. So what I do, of course, is command line, because we are devs, guys. So there are no amazing interfaces. And let me write on my second monitor the sentence.
AI is not magic. Let me show you behind the scenes.
Let me add some pauses, breakpoints, because that, of course, has been done by user interface of our product, but here I have to add by command line here. So I just added almost 1 second of pause before and less than 1 second after. Okay.
Okay, now we can read
here.
better.
So now is going to produce everything. And let me show you the directory. Here, as you can see, in the meanwhile, I'm going to produce each frame. And in the meanwhile, let me tell why I'm using the PNG. Of course, for quality reasons, because this is something that I modified 1 month ago, so it's most recent. I have to say that working with JPEG is more difficult than the PNG, because of the quantization of the JPEG algorithms. Could happen much more when talking about the green screen, is not so accurate, and using the PNG I have a more accurate information, and then works better. So it's going to finish, because produced all the frames, and
It's a strange non-demo effect, non-exceptions,
No, it's not
strange
exception. It's
errors.
going to merge
Seems to
everything
work.
with FFmpeg. So it's finished, and
Okay.
I can share you the video using the second screen.
AI is not magic. Let me show you behind the scenes.
Okay, of
Amazing.
course, the
It's
software.
amazing.
Yeah, it never, nothing is magic when talking about AI. Of course, having a quick view of the code here, generate sequence, we can pass a lot of informations like the background that can be replaced, the watermark, if how to normalize the audio, and also the curve settings. So again, that is to highlight that is not everything related to deep learning. We also do a lot of work with computer vision algorithms, and in this case with the OpenCV, because of course I don't do the background removal using the deep learning, but the OpenCV, for example. Or if I have to adjust some parameters like the luminosity, the exposure, I do with OpenCV. Anyway, this is very important to highlight the speed, because we produced this video in, let's say, 1 minute. Of course, I have a very good GPU here, but we are talking about less than 1 minute, more or less. A lot of people asked me, but this is most like the deep fake, for example. The technology behind is
So,
the
could
same
you
of the deep
clarify the
fake.
difference between a digital avatar
Yes,
and
this is
deepfake?
something different because, of course, both techniques share the idea of using autoencoders, the one that I'm showing here in this moment, but it's just an idea. We are talking about two different approaches. Here we start at the early beginning from a text. We produce an audio using speech to text, and then almost in real time we are able to produce the video. Okay, always of the same person, changing. We will see how just a portion of that video of the interested area. When talking about the deep learning, the algorithm is focused on swapping faces, and you have no control, for example, on what is said on the audio. So just from this point of view is really something different. But also producing that video is totally different, because to produce a deepfake video of a good quality, you need at least 3-4 days each time that you need to produce a small portion of that video. Here we produce everything almost in real time, so different scenarios. So deepfake swap faces, much more from an high level point of view. Of course, I'm not going deep talking about algorithms. Here we produce the content starting from a text in real time, so something different.
It's clear.
And in scenarios like this one, where, for example, our product is inside a web chat where you have to change the text related to each intent very, very quickly, and most in real time, you can't spend 4 days, 3 days creating just one sentence. This is a key aspect, for example. I don't know if you had a question, or I can continue.
Okay,
I have a question. You can continue, but I have a question related to how to put it in production. But let's discuss later.
Gianni, you have always this type of question.
Well, putting in production from which point of view? From the point
Of
the final
observing what,
product or this one?
meaning you say we have a text and we see that it can work almost in real time on your machine. So you input a text, it produces a video. But in the scenario we're mentioning, which we have a web chat with somebody, it's a website and stuff like that. It's a very complex and different scenario to put in production. That was my question.
Yes, of course. What we did is to produce web tools. So we have a suite for the final user that see nothing about the AI. The final user have his own interface where he changes basically the text associated to each inference, to each intent, and then when you say OK, when you click OK, just that 10 seconds, 50 seconds of video is produced, but of course not in real time, because here I produced in real time, and that's true, but in production we implemented a queue, so a priority queue, and then your request is taken in charge, and let's say based how busy is the queue, your portion is processed. When will be available, you will find the new video, but there is not a discontinuity in the service, because until it is not ready, simply you watch the previous video associated to each sentence. And
Thank you.
the final user can't manage all this stuff. What he sees is just an input text box and the intent. So tell me just what text the avatar have to speech, and I will produce for you. Of course, behind the queue is very, very important, because we can't imagine to have a dedicated GPU for each customer. I would love would be possible, but you can confirm that would be very, very expensive, and then the queue is the only way. So you have to. I can produce it in less than 1 minute, but maybe that you have to wait 1 hour, 20 minutes, 2 hours. I don't know. But
yep, understood. Thank you.
I guess that is not a big problem. So I said that the core idea turns around the autoencoder. I guess that everybody that deals with machine learning knows what it is an autoencoder, but in the summary, this is the architecture. Or we have two neural networks connected together, where the first part, named encoder here on the left, takes an input, and then, thanks to convolutional operations, try to extract the feature of that input, and producing a vector that is named the latent vector. It has also several names, that is very, very small, containing all the key feature of that input. In this case, is not just an image, as a lot of deep learning models that you may already seen, but the input is made by an image, a 2D audio, and 1D audio. Anyway, we extract all that feature, and then the second part that is named the decoder try to reconstruct the input image based on that feature array. So the encoder audio. This is more or less the architecture of the encoder audio. And I already said more than one time that we have two inputs. So a 2D MFCC made in the way I explained. So the current frame, one before and one after, with the length 1, and the key frame that here is in yellow on the right, with a different size, so with a window length of 2. And of course, in one case I apply a 2D convolution, in the other case 1D convolution, then everything is added together using 1, 2, 3, depends on the cases, but let's say 2 dense layers in order to produce the latent code. That in this case, we have a latent code of 512. So if we talk back to talk about deepfake, here there is another difference, for example, and I'm talking now about quality. Maybe in some movies you see that the deepfake has a stunning quality. Yesterday I watched a movie saying that when they showed there was a deepfake in 4K. I guess that in my knowledge there is no computational power nowadays. Maybe NVIDIA, but I don't know even NVIDIA itself is able to produce a 4K frame in deepfake. Anyway, say that, for example, if you download, if you use common deepfake software, you can see that the latent code has a dimension that spread from 64 to 128, maybe 256, but something really, really impressive, that kind of dimension. Here we have a latent code of 512. And the final frame that we are going to produce is up to 640 here in this case, while, for example, a deepfake, the best software right now that is in my knowledge produces frames with a size that is less 512. That's because different goals. Okay, here I can reach a much higher quality, also because I'm focused just in one task and just having one kind of input, in this case just one person. So I don't need a generic algorithm. Anyway, this is the encoder audio, and here the final architecture, and is most different compared to common autoencoder because it's not symmetric. So basically what I did is to use two encoders inside one big container named encoder. I splitted totally the encoder production from the video production. So the encoder audio that you see here has the same architecture that we've seen before. And in the side, we work with the image, the frame that we have in input, using, of course, the skip connection to help the model to have a better quality, of course. Here, there is something really, really important that makes the difference and for me, it was a pain to arrive to this result because it was not so easy to arrive to this a solution. If you paid attention here, maybe you see that just the encoder audio is connected to the Latin code. The image produces the convolutional operations, but is not connected to the Latin code. There is a reason why it's not connected, but is used just for skip connection. That's because I wanted that the decoder focuses itself only on audio features. Because I discovered that the audio is weaker than the image. So the image has much more information, is much more powerful than the audio, because we talk about 128 elements, maybe, okay, multiplied by 4, because we are talking about 3 plus 1, but nothing compared to an image that starts from 512 by 512. So there is a big gap, and what happened that the deep learning model learned to reproduce the final frame not because of the audio features, but maybe because he realized that the detail on my eyes, on my head rotation, was a very important detail, and then there was not the lip sync. So using this technique, I was able to tell to the autoencoder, to the deep learning model, well, you must focus to the audio, just on the audio, and then use the video information just to improve the final quality. Okay. So, but how exactly works finally the lip sync? Because maybe now we are curious about that. So I use a technique that is inspired to the in-painting, but where it is in painting? In painting is a common technique that is already used in softwares like even Adobe Photoshop for background removal or for image reconstruction. And how it works that you design a mask or an area that you want to reconstruct, and then the deep learning model tries to reconstruct that area based on the mask. So the idea was, okay, I give you a reference frame, then I design a mask. Using the audio information, I fill that region with the correct shape of lips. This is the idea behind using this approach. And here the image, the input image is already masked. That's important. Here is an example. So I created a mask here, and then in the center the reconstructed area, and here the difference on the right. So maybe now you can think, okay, it's very, very simple. Unfortunately not, because I studied a lot. You have no idea how much research I did on that field, because the shape, the size, and the behavior of the mask changes a lot on the final result. So maybe you see now this simple shape, but there is not just one mask, because I studied several masks, several shapes that must be used in specific steps. So, in fact, in my workflow, we developed a pipeline where basically we define some stages, and for each stage there are several parameters. So, for example, in stage 2, I use a specific custom loss function, and on custom loss function we could talk another hour, because there was a lot of research even for the custom function. And here, for example, I define if to use a dynamic face mask or not. What it means dynamic? Dynamic, it means that I use the landmarks to produce a mask that better fit the face of the actor. Now you can say why you don't use this approach in the first stage, why you need different masks in the different stages. Because after a lot of research, I realized that a small and more accurate mask doesn't help the algorithm at the beginning to give priority to the audio. Against, if using in the final stages a bigger mask doesn't improve the final quality, because for sure where there is the mask there is a bit decrease in quality. Anyway, for each steps, what we do is to swapping, for example, the training of the audio encoder. This is also one reason why I split that model in a separate model, because in this way I can control more easily the training of what happened in that portion of the machine learning model. So I can say, okay, I realized that training the audio and training the video also has different speeds, because the audio is simpler, and maybe, not maybe, for sure, because after a lot of tests, I realized that the video takes much more time than the audio to reach the convergence, so the best accuracy. And what happened is that without disabling the training of the encoder audio, the encoder audio met overfitting in some conditions, waiting that the video portion reached the best accuracy. So I say, okay, first stage, let's say, it's just an example, it's not so simple, but let's say 1000 of epochs train the encoder audio. After that threshold, disable the encoder audio. Again, in the fourth stage, come back to train the encoder audio, and so on. In this way, I can balance the training of both modes inside the same mode. We implemented also a custom learning rate decay algorithm that is based on the accuracy of the custom function, because I realized also that we can speed up the training having a much more accurate learning rate for each stage. So we studied exactly how it behaves in the average case, and then we developed a custom learning rate algorithm decay. And finally, of course, something that really changed and helped a lot the final result. Maybe it's easy to say, but using affinitous transformations is very, very useful, because scaling rotation, even luminosity. Now, maybe I want to add also working with the saturation helps the deep learning model to be more general. So helps the generalization of the deep learning model. Else, it learns too much on small details of each single reference frame. And that must not happen. So we are almost at the end. You already seen that when we do the inference, we produce each single frame, and then we put all together using common software named FFmpeg. It's important to use solutions like the optical flow. For people that are not aware what it is, maybe you already see a lot of times that watching Netflix, you put pause of the movie, and you see the frame that is blurred, like following the movement of the car of the scene. Basically, this technique, what it does, produces in a in alternative way, so not of frames, of course. It blurs, making a computation of the movement of the scene, blur a little bit some frames in order to improve the image perception of the movie and making it more enjoyable to watch. And we do the same thing. So I say to FFmpeg, so it's not up to me, enable the optical flow. And we saw that improved the final result, because if you don't use the optical flow, it works, of course, but it's a bit shaky. But it's not a deep learning problem. It's a common problem of all movie makers. If you have a shooting in a very high frame rate, could be strange to believe, but each single frame has an amazing quality, but the final result is a bit shaky. So it's not an issue related to this project. Anyway, optical flow is not enough. It's not enough because if we assemble everything using FFmpeg, even using the optical flow, we already have a shaky final video. Why? Basically because we are, even if everything is very, very complex, very, very accurate, but basically what I'm asking to my model is, okay, please give me the best lip position for the sounds A, and then please give me the best lip position or representation for the sound T, and so on, and everything is put all together and doesn't come from an original shooting. So the final animation is not smooth. And here we did again a lot of research and used an interpolation technique between frames. That is not the same thing of the optical flow, but basically what I do is to do an interpolation between, for example, in this case, the interpolation is 1, but it could be 2, 3. So you skip, in this case, 1 frame, and that frame is being reconstructed by interpolation. In this way, I avoid shaky movements of the final result. But this interpolation is not made on the final frame, so based on pixels, but we use a special technique as we do interpolation on the latent code of the autoencoder. In this way, what I do is to use the latent code of the first frame, the latent code of the third frame. I do the interpolation of both latent code. The result is the input of just the decoder portion of my model, and then here by magic, yes, here we can say by magic, is produced a frame that is really between those two. So I'm really confident that all the animation is smoother. Please, would you play the video so people can understand better what it means a video without interpolation?
Yes.
Ciao a tutti, sono la versione digitale della persona che mi ha prestato il volto.
Ciao, sono la versione digitale della persona che mi ha prestato il volto.
Ciao. Sono Giulia, un avatar dalle sembianze fotorealistiche, generato da una intelligenza artificiale.
Hi everyone. I'm the digital version of myself. That has been created through a sophisticated AI, result of an intense year of development, research, and most importantly, great passion. I'm the digital version of myself. That has been created through a sophisticated AI, result of an intense year of development, research, and most importantly, great passion.
Ciao, sono la versione digitale della persona che mi ha prestato il volto. Sono stata creata partendo da un testo, grazie ad un'intelligenza artificiale molto sofisticata, un anno di ricerca e sviluppo, ma soprattutto molta passione. Le intelligenze artificiali più evolute sono in grado di compiere dei ragionamenti. Io stessa so compiere delle deduzioni, grazie agli algoritmi con cui sono sviluppata. Sono super intelligente, ma sono pur sempre stata creata.
A nice timeline. We saw the evolution from your exploration to the final. Now let me show the clip without the interpolation.
Hello. Today, we will talk about digital avatars. What you see has been created by an automatic process.
Okay, maybe that using streaming, you could say, okay, I don't see the difference too much, but please believe me, in some situations, for example, the lip were too shaky or moves too fast. This is because maybe in some point there is a misunderstanding from the deep learning model about the exact sound to reproduce. I don't know why. Could be everything. So using this technique, we have a much smoother animation of the lips. This works, and this technique is great, but can be improved, of course, as everything. I have to say right now, just for English, even though we did some hacking and then we are going to use it also for other languages, there is, for example, a service provided by Microsoft, in this case is part of the Azure Cognitive Services, that is named the VCM, text-to-speech animation VCM. So what it is a VCM? VCM is a kind of international standard where, in this case for English, as you can see below, to each sound we match some specific shape of our mouth. And there is a Microsoft here, but of course the standard maybe could have a different code, but doesn't matter. For the sound A, we have the VCM with ID number 2, for example, or for V, the VCM with ID number 18. Pay attention to the fact that to different sounds you can have the same VCM number. So how we use this service that improved future our performances? I don't care why these services was born, because of course it's something that was created to animate cartoon avatars or cartoon puppets, but I leverage the information of where is the very important sound in the exact part of the audio, and then I can do a much more accurate interpolation. That's because, for example, maybe that compared to the previous example here, that without information I say, okay, I skip 2 frames, but maybe that the most important information was here and not here. So in this case, could happen that I miss some information. With this technique, I know where are the key information, and then I can say, okay, from frame 0 to frame 5, skip 4 frames. But in this position, because he's talking fast or because of the word, don't do interpolation. After, skip just 1. So we created a software that starting from this Microsoft service, and I remember that we use neural voices provided by Microsoft because an high quality service. I can show you, for example, here what we did. It is a JSON, and here I know that for the frame 0, of course, I have the VCM at 0 because everything starts with mute. But at the frame 21, I have the VCM number 12. And this is the timing. This is not an information that is provided by Microsoft in this format. It is our software that makes some computation starting from that information. And please pay attention that I don't use this value. For me, this is just a mark to know that here I have to do an interpolation. But I don't use this shape information. So because there is the VCM number 2, then it's an input of the deep learning model, because it doesn't work. And this shape is this information again is useful for cartoons, not in that case, but is useful just because I know here that between frame 29 and the next one, I have to do a lot of interpolation and not just skipping one frame. And the result is far away more accurate compared to the previous technique. So, of course, this is a big summary of the project. We can talk, we can do a deep dive of each single step of the algorithm, because 1 hour wouldn't be enough. But anyway, what was the goal here was to show you all the workflow and the key aspect of the algorithm. Of course, I'm available for people who has questions about the algorithm or some details of the whole workflow. You can write to me, keep in touch with me, and I will be happy if I can to share the info that you need. Finally, here we can talk. We could talk another session, because the hardware is an argument that is very painful, and what we used. So we have to say that for research and development, in my case, the cloud is not the way, because I changed the idea, techniques several times per day. So I had the need to try everything very, very quickly and moving gigabytes of data, because okay, maybe my camera is too much, because I own a Canon 5D Mark IV, and 6 minutes of 4K shooting is almost 20 gigabytes. For people that are able to speak in 6 minutes, there are actors that are not so good that maybe speaks in 12 minutes, because you need suggestion, you need more time, and then we are talking about 15 gigabytes. So to move very, very quickly just this amount of data to the cloud in very few time is not so comfortable. Everything could be done for sure, but how we worked. So we have our own GPU, so for development, and then of course we use the cloud, but just for the inference.
Very, very interesting. Before closing this fireside chat, let me show again the intro video.
Hello. Today, we will talk about digital avatars. What you see has been created by an automatic process.
Very, very cool. This is the output of your job.
Yeah.
Amazing
So
job. Yeah.
of course, I'm working now to improve the gestures, but much more to custom voice, because in this case, for example, the voice is very, very good, but is good for English and for that target. But let's say, for example, that a famous actor or speaker would request our avatar. In that case, you need to provide his own voice. And then we have to go in that direction. But not just for that, but also to improve future the performances. Because now it works that for training, I use the original voice from the shooting. And then as output, I use the neural voices from Microsoft. That works because the audio processing algorithms that I told you before works very, very well because it's able to extract the key feature and is helped much more by the deep learning algorithm and by the convolution and the architecture of the encoder that are able to extract very, very well the feature. So even we have two different voices, but both say the sounds A, the algorithm is most confident to say, okay, they are the same sounds. So it works. In fact, we have very, very good performances, even using models that are trained with English text in other languages. That could be Spanish, Italian, and Greek. I have to say that more than one occasion we had better performances in Italian starting from the English training, but not just because we used English input that is better, because we used the original voice. So maybe the language helps much better the algorithm because, for example, there are sounds like too much, for example, is much more clear than in Italian in several sentences. We did a lot of studies about that. The Italian, for example, is much more complex than English and has much more sounds and much more smooth. And then I have to say that sometimes happen that compared to the original shooting in Italian, we had better performances starting from English. And so, to say it works very, very well, but would be even better if I compare two similar voices. So, this is the reason why I'm going to push to have the custom voice. It's something I'm working on. You could say, okay, Microsoft has custom voices, for example. Unfortunately, it's not for everybody. So we did the request. We are still waiting for a reply, and not everybody can use the custom voice. But I need it. So if Microsoft will not provide a custom voice to me, I will make by myself. Of course, I hope don't do that because I don't like to reinvent the wheel.
I
Let's
fully
see.
understand this point. Anyway, thank you so much. Can you share some things in order to contact you or ask you more information? Okay,
This
perfect.
is my email address, Twitter, and LinkedIn account. So if you want to keep in touch with me talking about this project, I will be happy to do that.
Thank you so much, guys.
Thank you to you.
Thank you.
Thank you. Bye.
Bye.
Good night.